Hello, I'm Mike McCulloch. Today I'd like to talk about light in a different way. So this video will be slightly more speculative than some other ones, but I want to go back to the about 1900s when it was thought that light was a bit like a wave, a more familiar wave, the kind of wave we know about, ocean waves or sound waves. And it's of course known that ocean waves and sound waves require a medium to travel. So ocean waves require water or air-water interface, and sound needs air to travel. So by analogy, since light looked like a wave, people assumed that it required a medium. So the ether was invented. It was thought that there was this rigid background anchored to absolute space, which is a flawed concept, but anyway, it was anchored to absolute space. And so experiments were proposed to try to find this ether. So by analogy to Galilean dynamics, what happens if you're traveling relative to something else, if the car passes you at 60 miles an hour and you travel, you accelerate towards it at 60 miles an hour, then it appears to be static to you. So it was also thought that light speed would also vary on different parts of the Earth, because the different parts of the Earth would be moving relative to this absolute space. And so Michelson-Morley developed an experiment that measured this, and they found no difference in the speed of light, no matter which direction the experiment, which was sited on the spinning Earth, was going. So this was very puzzling at the time. So Michelson-Morley could not find any evidence of the ether. And then Einstein showed that what you could do to make everything fit is you could, well, first of all, you get rid of the ether entirely. And the second thing is that you vary space and time, which are abstract quantities anyway that you can never directly measure. You vary them such that the speed of light is always constant, no matter what your own motion is, what your own speed is. And this worked, and it predicts quite well. At least special relativity does. General relativity predicts well in the solar system, but not elsewhere, not in galaxies. But this approach of modifying the abstract quantities of space and time is philosophically quite abhorrent. It's philosophically wrong, because you can never directly measure space and time. You just can't do it because they're abstract quantities. We can measure them using proxies like clocks or rulers, that sort of thing, but you can't actually measure the mechanism here. So I think this is a problem. So is there another way to do it? Well, one way to do it would be to have a kind of ether that only appears or changes when you accelerate. So this would mean that whatever your speed is, the ether does not vary. Only when you accelerate does it change and affect things. This would fit Michelson and Morley, and because we're bringing back a kind of ether, it would be measurable. It would make this science testable again, directly testable. So how could we do that? How could we do it? Well, Unruh radiation is like this, because Unruh radiation is acceleration dependent. If you're not accelerating, well, in quantized inertia that can never happen, but if you're never accelerating, you don't see Unruh radiation. If you have minimum acceleration, you see some. And quantized inertia uses Unruh radiation. It's built on it, and it happens to predict galaxies and deep space dynamics and the dynamics of nanocavities very, very well as well. And so this is a far more testable way to get the same effects that special relativity predicts, using these very abstract modifications of space and time that can never be directly tested. It's not abstract, so it works. Quantized inertia works on gradients and unradiation, which is directly testable. We can test the predictions of it, of course, in dynamics for galaxies and thrusters and that sort of thing. But with this explanation, unlike space and time, the abstract quantity of space and time, we can measure whether it is actually unradiation that's causing the changes, because we can measure the actual radiation. Unradiation has now been seen by Lynch et al., and so it can be seen and directly tested. So we can test the consequence, and we can also test the actual mechanism. So philosophically or scientifically, this is much better. Okay, so I hope you enjoyed this short, and I look forward to doing another one tomorrow.